All right, guys, welcome to another week of physics at the Roman House. This week we're going to talk about reflection. So with reflection, we're going to start with a plane mirror first. And so first of all, a plane mirror, something that's nice flat surface, and that is completely reflective. This is called a specular reflection, as opposed to a diffused reflection. It's something like this, where it reflects, but it's kind of distorted and it's not a flat surface, and it's because the rays are coming in and hitting all the different surfaces that are the bumps and cracks and things like that. Okay, so with our plane mirror, there's a few things that we need to understand. First of all, when you look in a mirror, as you do, you are actually looking at yourself in a virtual image. So a virtual image is something that appears that we can see in the mirror, but doesn't exactly exist. So I have my assistant today, which is Pumpkin. So Pumpkin here, Pumpkin's a little guinea pig, and he's gonna demonstrate how mirrors actually work. Okay, so Pumpkin's gonna go on the table here, and he's looking at himself in the mirror. Okay, so we have Pumpkin here. He's looking at himself in the mirror, and he is about 30 centimeters in front of the mirror. And so when he sees himself in the mirror, what he's actually looking at is his virtual image that is 30 centimeters behind the mirror. So he is 30 centimeters in front, which means his image appears 30 centimeters behind. So that's a total of a 60 centimeter difference between him, who is the object, okay, and his image, which is a virtual image. And we're going to discuss virtual images versus real images when we get to to curved mirrors, because in curved mirrors you can see those real images, versus in plane mirrors we always see a virtual. Okay, so if Pumpkin were to walk around here and look behind, there's not going to be anything back here. All right, and so what happens is that his eyes, he's looking through the mirror. If he looks at the top of his head, he just passes right through. If he's looking at his toes, he would angle his eyes down a little bit. And so what he's actually seeing is reflecting off the mirror and back, as opposed to the virtual rays that actually continue on to actually see him, or see his image. So I'm going to draw out a few examples, so a few ray diagrams of that to show you what it actually means. All right? Thanks, Pumpkin. Okay. So here we have one of my amazing drawings. We have a picture of a stick figure, and so he is our object. All right, and this is the mirror, and then behind the mirror over here, this is going to be his image. And as we already discussed, it is a virtual image because he's not actually there. All right, and so if this little guy wants to look at the top of his head or his eyes, he just lines up directly like that. And so when he looks, it bounces off the mirror and actually comes back so he can see. What it appears to be doing is that it appears to go through the mirror to where his virtual image would be. But really what's happening is right here, it's bouncing off so he can see his eyes. Now, a different part is if he wants to look at his shoes. All right, so his shoes are actually right here. And as we remember from last week, light from around the surroundings has to actually hit this to be able for us to be able to actually observe it. And so what happens when he wants to look at his shoes down here, he's actually going to line up his eyesight with his virtual shoes on this virtual guy over here. All right, and as we know, light can't actually pass through a mirror because it's a solid opaque surface, but it appears to go all the way to his virtual shoes. What in reality is happening is that right when it hits the mirror, it's actually reflecting off in that manner, like that. All right, so here's his shoes. All right, so for him to observe his shoes, he lines it up, his eyesight, with his shoes, but it actually bounces right here and comes back to his shoes. So that's the actual path of the rays to be able to see his shoes. And the last thing here is, if you notice, for you to look at both your lovely hairdo and your shoes, you actually only need a mirror that is about half your height. Because when you look at your feet, you're looking halfway down this mirror in order to see your virtual shoes over there. All right, so we're going to look at a few more ray diagrams and get some more vocabulary. So if you look at this picture here, we have our mirror, which is flat on the ground. And one of the things to point out, we have all of the colors of the rainbow that we learned about last week. Notice that none of them actually get absorbed. And so that's what makes um, a mirror is that it doesn't absorb those light rays, it just automatically reflects them all. And so perpendicular to the surface, this is this imaginary line, which is called the normal. And if you remember back to our forces unit, the normal force is perpendicular to the surface that the object is sitting on. So those terms are common. It is perpendicular to the surface of the mirror in this case. So we have our incident ray that's coming in. And so I always remember incident ray that's coming in. And then it hits the mirror and it gets reflected out, which is our reflected ray. Now, the important thing to remember here is that if you look at this diagram here, your angle of incident, which goes with your incident ray, is actually between the incident ray and the normal, not the mirror itself, but it goes from the incident ray to the normal, and then from the reflected ray to the normal is your angle of reflection. And it's important to be measuring those from the normal. Now, our laws of reflection state that your incident angle and your reflected angle for a flat surface are going to be the same. So if this is coming in, this kind of looks like maybe a 45-degree angle. So if it's coming in at a 45-degree angle, then it is being reflected at a 45-degree angle. Or if this was a little bit steeper, it's coming in at a 30 degrees right here, it would be 30 degrees right here as well. Okay. So here's an image of a little bit nicer man here as opposed to my stick man. But again, if this man wants to see the top of his head, he is actually going to be looking and then it reflects back to see his head. Where behind the mirror, virtually, it actually goes right to his head. Now, the light ray can't actually go through the mirror. It reflects back, but this is what it appears to be. All right, same thing looking at your shoes. He is directing his eyesight towards his shoes here, but it is reflected right in the middle. And you can see here, if you were to draw a normal line that kind of cuts this right in half here, you would see that those angles, the angle of incident and the angle of refraction, are the same. And lastly, if you are looking at something else in a mirror. So if this object is beside you, if you're in your bathroom and you're kind of looking in your mirror to look at something else, then same thing that you do here, your DO, this is the distance of the object. This is DI, which is your distance of the image. And once again, your DO and DI are the same. So if this object is, let's say, 10 centimeters in front of the mirror, this is going to be 10 centimeters behind the mirror, which in total would be 20 centimeters away from the object itself. So when the eyeball, and I know it's kind of looking forward, but it's an image, we can pretend. If the eyeball wants to look at the top of the image or the object, okay, it directs its eyesight towards the top. And so this is one straight line, but notices that it stops here and angles back. Same thing if it wants to look at the bottom, it lines up with the bottom of the image over here, but it actually bounces and reflects back. Now, the reason these arrows are backwards, they're actually the correct way, I kind of say them backwards, is that the eye is what we are observing. And remember, we talked about this last week, that the only time you can ever see something is when that light ray actually hits your eyes. So when you're actually looking, you're actually seeing this image being projected back into your eye. You'll be able to notice that. And this is pretty much how we do plane mirrors. Up next is going to be curved mirrors, which are a little bit cooler.